Okay, Unit 3 test review. Just to be forewarned, this is probably going to be a long video. I may cut it down into 2 parts. Either way, it will be lengthy because there's quite a few problems to do, and a lot of them are going to involve the calculator. Remember, you don't have to watch the whole thing. Watch what pertains to you. Watch what you're weakest in. Watch what you're struggling with. Okay, so number 1, we're always read directions, name the domain and range, and tell whether or not each is a function. Explain why or why not. Write the inverse of each as a set of ordered pairs. Okay, so the domain is just your, remember, when you have numbers and tables and bubbles, just the domain is just the values listed. So -1, 2, and 3. Horrible attempt at braces. My range is -3, 6, and 8. Is it a function? Well, there's no repeats in my domain, so yes. Another way of saying it is each input has only one output. Way of writing it. Okay, and then the inverse, if you look at each of these as an xy, 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 the inverse would be just switch them. -3, -1. 6, 2. And 8, 3. In fact, number 2, I'm just going to get the inverses out of the way right now. 1, -2. -3, -2, -4, 2, and 3, 2. Oh, just notice, is the inverse a function? So on number 1, I have -3, 6, and 8. Yes. On number 2, I have a 1, a -3, a -4, and a 3. So yes, it is. Now the domain of number 2. Well, notice I have a couple -2's. I only have to write it once, which also tells me, no, it's not a function. Because I don't know if -1 is going to yield a 1 or -3. So at that point, I know it's not a function. So -2, -4, and +2 are my domain. My range, 1, -3, 2, and +3. Those are my y values. Why is it not a function? -2 has 2 outputs. Okay? My domain, -4, 2, 3, and 8. Those are my x values. My range, -4, I only have to write 1 once, and 9. Is it a function? Yes, it is. Each input has only 1 output. Now I'm going to flip them, reverse them. -4, -4 is still -4, -4. No big deal there. Then I have 1, 2. I also have 1, 3. And right at that point, bells should be going off in your head saying, whoa, whoa, whoa. Does 1 give me 2 or does 1 give me 3? It gives me both, which means no, it's not a function. And last but not least, 9, 8. Number 4, figure out what's going on here. Well, I wouldn't write anything down right away, because you never know, you might have to erase. If you're using pen, definitely don't write down. If you use pencil, who knows? This is what happens. So from 1/2 to 1 went up by +0.5. And then it went up +1, and then it went up +2, and it went up +4. Okay? And then you check your second level and go, well, it went up +1 and +2, and +2 is +1 plus 2 is the same thing. So evidently that's not it. But this is double, this is double, this is double, and this is double. That's exponential. 9 to 4, -5, -3, -1, +1. -2, sorry, +2, and then +2 again, and then +2 again. Since the second level is where it works out, that's quadratic. And here we have +3, +3, +3, +3. That's linear. Okay, number 7. Identify the transformations. Describe what is happening on each parent graph. Okay, well, first off, this is linear. And it's linear because it's to the first power. Now, what's happening? It's being moved down 3. And the 5 is making it narrower, or climbing faster, or stretched vertically, whatever works for you. Number 8. This little 2 tells us it's a quadratic. What's happening? It's being moved up 1. Okay? This -2 means right 2. And this negative inside flips over the y-axis, not the x-axis. If the negative was on the outside of the parentheses, then it would. Number 9. We see the absolute value bars. Down 5, shifted down 5. This negative flips over x-axis. The 3/2, even though it's a fraction, remember that's really 1.5. So that makes it narrower. And this +1, since it's inside, does not make it move right, it makes it move left 1. Now remember, you have access to a graphing calculator. Make it your friend. So, go back to your paragraph for number 7. Y equals x. Graph it. Now, take your calculator, go to 2, and put 5x minus 3. And see what happens. It's steeper, narrower. You know, it doesn't really apply for a linear equation. That's why you might want to say steeper, or climbs faster, or stretched vertically. And it's also shifted down 3. And if you ever need points for graphing or comparing the two, there you go. Always go back to your parent function. Number 8. This is a quadratic. Your parent function is x squared, which is going to be your parabola. Come back for number 2. Parentheses, negative x minus 2 close parentheses, square, plus 1. Okay? So remember, we said write 2, okay? Which it does. But then it flips over the y-axis and ends up being back over on the other side. And then number 9, again, absolute value. So that's under the math key, over 1, enter, and then x. Close parentheses on that. On yours, yellow ones, you just let it go. So there's your parent function. So now we go back to y2. And we're going to put in negative, and then 3 divided by 2. That's how we enter a fraction. Math, absolute value, x plus 1. I have to close it here. You'd have the absolute value bars. Minus 5. So it's gone down. It is flipped over the x-axis, and it is narrower. And yes, in case you're wondering why why narrower became wider, it's going to flash back to narrower. I made a mistake, and I went back to correct it, and I messed up on the editing a little bit. So this is narrower, and it's narrower, like I said the first time, because 3/2 is greater than 1. I messed up and actually put 3/5 into the calculator on the initial one, so when I graphed it, it looked wider, and I second-guessed myself and messed up. So moving on. Number 10, cubic function. It's going to be up to, and it's going to be flipped over the x-axis. So what does it mean for a cubic function? Well, let's look at that. Okay, x cubed. So we're going to do x caret 3. That's our snake, right? Now, when we come back to do the second one, it's going to be negative x to the third power plus 2. So when it's flipped over the x-axis, it ends up looking kind of backwards, like a mirror image. But if you think about it, the upper right part folded down, and the lower left part folded up. That's why it works that way. Okay, number 11 is exponential. Okay, technically because of this 2, it's growth. But you can just write exponential. It's going to be moved up 2, and this negative 1 is going to move it right 1. So once again, your calculator, you can fast forward through these or to the end, same time, but we're going to practice this calculator. So 2 to the x is the parent function. There's your growth. Then we come back, down, and do 2. Now on this one, I have to put in parentheses. You don't on the yellow ones. X minus 1. You just have to arrow up and down. And then I put plus 2. Notice it's up higher and it's shifted over to the right slightly, right 1. Okay, absolute value again. Up 1. And 2/5 is going to make it wider. Okay. Moving on. Identify the type of function and sketch the parent graph, then graph the function using transformations and give the domain range. Please remember, we'll have it right there. Please remember, graph the parent graph, then graph after the transformation. Do both. So, type, absolute value bar. If you don't remember, absolute value starts at 0, 0, and goes diagonally up both directions. If you need points, go ahead and use your graphing calculator. Now, what transformations? Down 3, left 1. So you can just take the vertex, if you want, just from here, and go down 3, left 1. So 1, 2, 3, left 1. And then you really can just go up diagonally through like so. You really don't need a lot of other points. But once again, if you want to, use your graphing calculator. Should have done that because of absolute value. Well, you know what the original one looks like. So you can put it in. Or, right here, math over. These are good things to practice. X minus 1 minus 3. So down 3. Sorry, not left 1, right 1. Right, not working. It's the opposite of what we're thinking. But if I didn't catch it there, I would have caught it using the calculator. So I did mess up though when I graphed it, which is why it doesn't hurt to double check. So down 3, 1, 2, 3, and right 1. And now I graph it up this direction. So see, the thing is, guys, mistakes happen, and it's okay. We all short wire times. You're going to make mistakes. That's why it's not a bad thing. It doesn't mean anything negative if you use the calculator. If nothing else, just to double check. If you want to, you can always double check points on here also. So the domain of my transformation. We're doing the domain on this second one. So again, domain is how far left does it go? Well, it's going on for infinity. How far right does it go? Infinity. Range. How low does it go? This is always first. How low? Well, -3. And remember, this kind of tells you where that is. -3 with a bracket. How high does it go? Positive infinity. And remember, if you write it, switch the places, you will lose partial credit, so be careful on that. Okay, x squared. You can use your calculator, or hopefully you know by now, 0, 0, 1, 1, and -1, 1, -2, 4, and +2, 4. You should be able to do this without calculator. 3, 9, and -3, 9. There are your points and your parent function of the parabola, x squared. Okay, the +2 is going to move it up 2. This +1 is going to move it left 1. And remember, this little 2 here is what tells you it's quadratic. So at this point, you can use the calculator or just take these points and go up 2, left 1. So up 2, left 1. You can use a different color if I want to. And then take this point here at negative 1, 1 and go up 2, left 1. And take negative 2, 4 and go up 2, left 1. And there's my new parabola. Again, I can use my calculator though to confirm. X squared graph. Oops. I had this a little negative here, didn't I? I'm on a roll. Attention to detail. So this negative is going to flip it over the x-axis. It's going to turn it from a smile to a frown. It happens. So, here's your calculator. Again, there's a little negative there. X plus 1, parentheses, squared, plus 2, graph. So it's the same thing, it's upside down. So here, if counting that off the chart is hard, go to your graph and your table. So 0, and we're using the y2 column. So 0, 1. And 1, negative 2. And negative 2, positive 1. I'm just using one of my hands, so I have to flip back and forth. So negative 3, negative 2. There's the matching one over here. And negative 2, positive 1. And negative 1, positive 2. I did it upside down. And so there you go. This one doesn't belong. And there's your transformed function. Now, what's my domain of the new one? How far left? Again, parabolas go on left and right forever like that, unless they have endpoints. The range. How low does it go? Here's where you don't want to get backwards. Going towards negative infinity. How high does it go? Positive 2 with a bracket. Okay, more of the same. We have the x up in the exponent, which means it's going to be exponential. Technically, it's decay, but you can just write exponential. This 1/2 tells us it's decay, because it's less than 1. Then, this plus 1 is going to move it up 1. This plus 2 is going to move it left 2. Okay, to save time, I'm just going to enter these in the calculator while paused. So I can put it in as 1 divided by 2 or 25 raised to the x. On this calculator, I have to put the x plus 2 on transformation in parentheses. You guys, once you hit the caret, it puts it all upstairs. You just have to remember to arrow out to go right, to drop it down and do the plus 1. So there's my decay. And there's my other decay. Notice it's up 1 and left 2. So now I just get some points. Now I have the same readout on my graph calculator in my hand so that I don't mess up. I'll have to go back and forth. So I'm going to put in the original one first. Negative 3, 8. Negative 2, 4. Negative 1, 2. 0, 1. And now you can see, remember, it's just never going to hit 0. So there is your parent function. Our second one, I'm going to use the y2. So negative 5, 9. So notice, look at that point right there. Is that point up 1 and left 2? Yes, it is. And I can do that with each one. I don't have to use a calculator if I don't want to. I can go up 1, left 2. And from this one here, I go up 1, left 2. And from 0, 1, I go up 1, left 2. And remember, where am I not going to hit? This time, 1. Okay, so there is my transform function. Now the domain, still going left and right forever. My range, how low does it go? And that's this border right here. How low is it going? Positive 1. We get that from right here. But remember, we have to use parentheses. How high is it going to go? Up towards the sky, infinity. Okay, number 16. Square root function. Okay, what's transformations? Down 3. Left 1. So go ahead and put this in the calculator. Okay, so I've entered this in, square root of x. Now remember, on your calculators, if you use these room ones, they actually put the radical over the x and you keep going until you arrow out. So once you hit that 1, you right arrow, come out from underneath the radical and write the -3. So when I graph this one, there's what I get. Okay? And I can go to my table and get my points. I have a lot of errors because I cannot have the square root of a negative, right? So I'm going to use these points right here and graph them. So again, my parent function starts at 0, 0. And then I have 1, 1. Square root of 4 is 2. And the square root of 9 is 3. And there's my parent function. And basically all these points, I can use a calculator or I can go down 3, left 1. So from this point, I go 1, 2, 3, left 1. And from 1, 1, I go 1, 2, 3, left 1. And check your calculator. Do you have a point at 0, -2? Yes. Do you have one at -1, -3? Yes. So you can use the calculator to confirm. So from this point, 1, 2, 3, left 1. 1, 2, 3, left 1. And there is my parent function. And my transform function. Now the domain, again, how far left does it go? It's going to hit -1. And it's going to actually touch it. How far right does it go? Positive infinity. How low does it go? That's this borderline right here. That's -3 included. It's touching it. How high does it go? It's going to keep getting higher and higher over time. Slowly, but it's going to get there. Positive infinity. Okay, number 17. Piecewise graph. We have 3 separate graphs to do. Now remember, you can do this the longer way, which is graph y = 6. There's the horizontal line. Okay. Now I'm going to show it the long way, and if you want to fast forward to the calculator way, go ahead. So y = 6 is a horizontal line through +6. But I want to cut it at -2, which is right here. I'm going to cut it, but I'm going to use an open dot because that is just less than. So at -2, 6, I'm going to put an open dot and go that way. Now for the second one, it's x squared - 4. So if you think about it, this is our classic parabola. Just drop down 4 spots. So it's up to you. You can use a calculator or do what you know. So we know our original point would be at 0, 0. So it's just going to drop down 4 spots. Then we have 1, 1. 1, 2, 3, 4. And it'd be there. And then we have 2, 4. So it's going to just drop down like so. And 3, 9. So we just drop down 4 spots. 1, 2, 3, 4. And that'd be over here. And so this is our parabola x squared - 4. But we don't want the entire parabola. We only want between -2, that's going to be a solid dot, and positive 2, which is going to be an open dot. So we go to negative 2, we want that solid dot right there. And then we're going to get rid of the rest of it, like so. And then from here up, we're going to get rid of it. And the other thing is, we want to circle here. And that's x squared minus 4 in between 2 and negative 2, not including positive 2, but including negative 2. And then the last one, graph line, negative 2 is our y-intercept. And we're going to go down 1, right 2. And we're going to keep doing that. Or we go up 1, left 2. And there's our line. But remember, we only want everything greater than or equal to positive 2. So that means our dotted line is coming through positive 2 right here. That's it right there, is that point. I made it a little bit big, but just for effect, going that way. Which means I want to take my eraser now and erase all of that. Everything in there. Technically everything right there. Clean up the dotted line. And there is my piecewise graph for those three. Now, if I want to use the calculator to do that, this time I'm going to do each one on its own. Y equals 6, and graph. And then I use my table, and I want numbers less than negative 2. They're already here. But let's say it was, like so. I don't want numbers like 1 and 0 and negative 1. So I can just scroll this until negative 2 is at the bottom, and there's my points. It's pretty easy with a horizontal line. Then I'm going to clear out. I'm not going to put them all in one graph because I can't cut them on here. So I'm going to put x squared minus 4. And I'm going to graph that. But remember, I only want between negative 2 and positive 2. So I'm going to move my buttons down until negative 2 is at the top. And that gives me my points. I'm going to put negative 2, 0, which I have, negative 1, negative 3, 0, negative 4, 1, negative 3, and 2, 0, remembering that that's an open dot. And I don't use anything else. Now, I would just plot those points and draw my problem, I'd be there. And last but not least, negative 1/2. I can put negative 0.5 or negative 1 divided by 2, either way, x minus 2. And graph. And there's the line we have, but remember, I only want numbers greater than or equal to 2. So I'm going to move this down until I get rid of all those numbers less than 2. 0's gone, 1's gone. And there we go. And I can put points at negative 2, negative 3. Positive 2, negative 3, 4, negative 4, 6, negative 5, and so forth. I can use decimals if I want, but that's just easier. And there is my piecewise graph. Well, I use the calculator or the long way. Now, to determine h negative 2, I go to negative 2, and I look at my dotted line, and see, is it going to hit the horizontal line? No, because it's an open dot. Is it going to hit my diagonal line? No, because it starts at 2 and goes right. So it's just going to hit my parabola. Where does it hit? Right there at 0. H of 5. So I go to 5. And I say, hey, where's it going to hit? Well, it's not going to hit my horizontal line. It's not going to hit my parabola. It's going to hit my slanted line. But where does it hit exactly? I'm not sure. I need to plug 5 in right here. I can do the math in my head, or my calculator, I can see it says right there, 5 gives me negative 4.5. Again, use the calculator is your friend.
Now I'm going to stop it here and make this the end of the first part.